Hello, this is Angela Robinson, coming to you from Durham Technical Community College, here to talk about some key features in your Introduction to Programming Logic and Design course. In this video, I will be talking about the two kinds of repetitive statements, count-controlled and condition-controlled. A count-controlled loop is when you need to do something for a specific amount of times. You do this by utilizing a counter variable, called counter for short. Within the loop, you perform three tasks to the counter. First, you initialize the variable to the minimum value. Second, you test the variable's value to see if it's between the minimum and maximum values. If it is, the loop continues to perform the task. If it isn't, the loop is stopped and the program goes to the next task. Third, after you perform the task, you increment the counter variable. Although you can write any loop as a count-controlled loop, there is one repetitive statement that is used specifically for count-controlled, and that is called the for loop. Here is the syntax of it. You start with the for keyword, followed by the counter variable name. After the counter, you show what the minimum and maximum values, or the start and stop values, of the counter should be. After the statements are performed, the loop checks to see if the counter is at the maximum value. If it isn't, the program increments it by the value that you choose. Then the program repeats the statements and checking of the variable until the last value is reached. Here is an example from the brushing teeth program I made. I'm applying toothpaste to the toothbrush. Let's assume that 0 for squeeze means that I'm not squeezing the toothpaste tube, and 1 means that I am squeezing it. To get the right amount of toothpaste onto the brush, I need to squeeze the tube for 3 seconds. So, I set my counter variable, second, to 0 and will be counting to 3. For each second, I turn the variable squeeze to 1 to put the paste onto the brush. After 3 seconds, I stop squeezing the tube of toothpaste. Here you see the flowcharts I have made to show a for loop. The left one is the usual way of doing a for loop in flowcharts. The right one is showing the syntax of Raptor. Notice that Raptor is backwards from the normal way of doing it. Because of this, I had to change the comparison expressions in the diamond shape. When preparing your programs in your class, keep this in mind with Raptor syntax. Let's move on to the condition-controlled loops. These loops use a Boolean expression, much like the decision statements, to decide if the loop should proceed or end. You use this kind of loop when you're not sure how many times you will need to repeat the task, or when the amount of times to repeat can vary. Many programmers design condition-controlled loops using what is called a sentinel. This is especially true when they are having the program ask the user to put a list of information in, like employee hours. There are three kinds of condition-controlled loops: the while loop, do-while loop, and the do-until loop. The while loop runs statements as long as the Boolean expression is true, and is considered to be what is called a pre-test loop. A pre-test loop is a loop that tests the Boolean expression before it runs any of the statements. Most programmers use the while loop when there is a chance that the condition is false to begin with, and you wouldn't want the statements in the loop to run at all. The syntax of the while loop looks much like the if statement, but with different keywords. You start with the keyword while, followed by your Boolean expression and the then keyword. Indented below are the statements to perform when the loop is running, and as always, you end the loop with the end keyword. Here we take the toothbrush example a little further. As mentioned in earlier videos, the program doesn't know to do the small things. So in my while loop, I tell the program to hover the toothpaste over the toothbrush and to only squeeze while we are hovering the paste over the brush. Notice how we check to see if hover is on before proceeding to do anything else? Here I show the flowchart of the while loop in both normal and Raptor syntax. Again, notice how Raptor does the loop backwards. Just like the while loop, the do-while loop performs statements as long as the Boolean expression is true. The difference is that this loop checks the condition after performing the statements instead of before. This is called a post-test loop. It is best to use this loop when you always want the statements to run at least once, no matter if the Boolean expression is true or false to begin with. Here is the syntax of a do-while loop. The do keyword is the only thing on the first line of the loop. Next come the statements that you perform during execution of the loop. This time you end the loop with the while keyword followed by your Boolean expression. This last line indicates the post-testing. Here I show the same code for applying the toothpaste, only I check to see if hover is on after the statements are performed at least once. Here are the flowcharts adjusted for the do-while loop. Notice the diamond for checking hover is at the bottom of the loop instead of the top. Do-until loops are much like do-while loops. They are post-test loops, where they check the condition after performing the statements. Also, no matter if the condition was true or false to begin with, the statements within the loop will perform at least once. The difference here is you're performing these statements until the condition is false. The syntax is exactly like the do-while loop, but instead of the while keyword, you have the until keyword. In the pseudocode and flowcharts of my toothpaste applying example, all I need to do to convert it into a do-until loop is change the last line of the code and what is inside the diamonds of the charts. As with decision statements, you can nest loops as well. In fact, you can nest decision statements within loops and vice versa. You may have noticed that I did a nested for loop inside the conditional loops here. When designing your program, you need to make sure that you don't have infinite loops. Infinite loops are loops that never end. This is caused when the programmer forgets to put in code to change the condition to the opposite of what it is, true or false. For example, if the condition is true to begin with, and you're using a do-while loop, you need to make sure there is code to make your condition false. Here I show two flowcharts done in Raptor. The one on the left is an infinite loop. Can you spot the difference? The one on the right has the increment of the counter variable, which allows for the condition of the second variable to be false at some point and end the loop. When writing your pseudocode or making your flowcharts, you want to make sure that you put notes in somewhere to tell the programmers what it is you are wanting this to do, even if it seems obvious by the code. You especially need to do this when working with a team of developers and programmers. Every programmer and developer designs their programs differently. When you put notes into your program, it's called commenting. Since you don't want the computer to think that your notes are part of the instructions to run the program, you have to put them in one of two ways. The single line comment is put in with a double forward slash at the beginning of each line. The multiple line comment is put in between a forward slash coupled with an asterisk on both sides. Some languages may vary a little on this by coupling with two asterisks and putting an asterisk at the beginning of each line to show it as part of the comment. Here is an example that shows a comment in our Apply Toothpaste code. Let's review what we've learned about in this video. Take a minute to answer the questions on the next few slides. The answers will show about 5 to 10 seconds after the question shows. If you need more time than that to come up with your answer, pause the video before the answer shows.